Hello everyone, I am Dr. Rajesh and I welcome you in this video lecture. In this video lecture, we will study one more problem based upon Lami's theorem. The statement of the problem goes something like: a body of mass 26 kilograms is suspended by two strings 5 and 12 centimeter long, their other ends being fastened to extremities of a rod 13 centimeter long. Okay, and if rod be so held that the body hangs immediately below the middle point, so this line has a punch, hangs below the middle point. Find tensions of the string. So we have to find the tensions of the string. So we will try to draw the figure and understand the figure first. Like we have two strings, if we take this as 13 centimeter long, take it in the horizontal position. Okay, this is 13 centimeter long and 5 centimeter and 12 centimeter strings are supporting the weight 26 grams the mass. So 5, firstly 12, say this one is 12 and this one is 5. Fine, draw it some in proper. This is 5. If I write it as, this is 5 centimeter, this is 12 centimeter. But this figure is not justified because the middle point of the figure is this one, and the weight which will be attached exactly at this point. Fine, so this mass M, which is equal to 26 grams, is not hanging below the middle point of the rod, and if we name it as AB and name it as C, so this orientation of the rod in horizontal position is not correct. So this position is not correct, because in this position we cannot extend this rod and cannot make both the rods equal, because we have to also take in consideration their length. This is only 5 centimeter long string, this is a string, so there will be tension T2 and T1. So now firstly we shall see how this AB will be oriented. So if we take AB in this position, say this is AB, and this is the middle point, this is 13 centimeter long, so this is the middle point. Fine, so this is the middle point, and if we draw a line exactly through the middle point, so what we'll get? We'll get this line. So and if now we join, this will be 5 and this will be 12. This figure, this orientation of AB will be justified. Fine, now I am going to join these two. This is joined and fine. Now this orientation of the road AB, and these are the strings, fine, and say these are connected at point C, and these are the string, and these strings are supporting the weight which is exactly in the vertical direction, fine, and this mass is 26 grams, fine. So these are the string, so there will be tensions, and this is say T1 and this is say T2, fine, and this string is smaller one, so this is 5 centimeter long and this is 12 centimeter long. Now this figure is correct because in this this figure the orientation of AB is in tilted position, and not in horizontal position. So this figure is wrong. So I am going to rub this figure from here. So I have removed the figure from here. Now we'll see if this is 5, this is 12. By Pythagoras theorem we know that 5 square plus 12 square is equal to 25 plus 144, which is further equal to 169, which is equal to 13 square. So 5 square plus 12 square is equal to 13 square. Instead of 169 I am going to write 13 square. So by Pythagoras theorem 13 is the hypotenuse, and opposite to hypotenuse we have 90-degree angle. So this angle is 90 degree, and if I mark this angle is 90 degree, fine. So this angle is 90 degree, and if we suppose any angle as theta, so what will be the other angle? That angle will be 90 minus theta. So let me mark the angles over here. This angle says theta, fine. So this will be 90 minus theta, fine. Now see, if this point, I name this point as point D. If this point is named as point D, then we know that this D is the middle point of AB. Therefore I can write here as AD is equal to DB. And if we, this is right angle triangle, ABC is right angle triangle. If we join the middle point of the hypotenuse to the opposite vertex of the right angle triangle, then we join the middle point to the opposite vertex, then that is also equal to these two. This is the geometry. So this DC, this is also equal to DC. This is by geometry. So these triangles, now this side is equal to this side is common, so these two sides are equal in both the triangles. So these triangles ADC and BDC are isosceles triangle. So in isosceles triangle, two sides we have equal, and we also know that the angles opposite to these sides are also equal. So angle opposite to this is this one, opposite to this one is this one. If this is theta, so opposite to this one will also be theta. So if I mark this angle will also be theta, fine, and this angle will be this side and this side both are equal. So in isosceles triangle, this angle is 90 minus theta. This is opposite to this one, and opposite to this one will also be 90 minus theta, because in isosceles triangle two angles are equal, two sides are equal, so their opposite angles are also equal. So this angle will also be 90 minus theta. Am I clear up to here? So now write by Lami's theorem what we get. Let me write it over here. The forces are, if we write it as weight 26, T1, T2. So this will be T1, T2 and the mass 26. Sine of the angle T1, this is T1, angle between T2 and 26. If this angle is theta, look over here, this angle will be 180 minus theta. So I am going to mark this angle as 180 minus theta. So this will be 180 minus theta. Fine. What about T2? T2, angle between T1 and 26. This angle is 90 minus theta. So this will be, when 90 minus theta is subtracted from 180, so we are left with 90 plus theta. So this angle will be 90 plus theta. So this will be sine 90 plus theta. 26, angle between this CA and CB is 90 degree. This angle is 90 degree. So this will be sine 90 degree. Fine. So this will be T1 upon sine theta, and this will be T2. Sine 90 plus theta is cos theta, and is 26 by 1. From here we get T1 is equal to 26 sine theta and T2 is equal to 26 cos theta. Now in triangle A, B, C, what will be sine theta and cos theta? If this angle is theta, this angle is 90 degree. Fine. So opposite to 90 degree is hypotenuse, and opposite to this one BC upon AB will be sine theta. So here sine theta will be BC upon AB, and BC is 12, AB is 13. Similarly AC upon AB will be cos theta. This will be 5 by 13. So I am going to put it over here. T1 is equal to 26, sine theta is 12 by 13. This will cancel out. So T1 is equal to 24 grams. Similarly T2 is equal to 26 into 5 by 13. This will go on, and T2 is equal to 10 grams. Fine. So this is the tension in the string. One is 24 grams and another one is 10 grams. So that is what we were required to. You have to write the limit same as given that of the mass, 26 grams, so it will also be in grams, because all are the equal forces. So in this we have also used the Lami's theorem, and this question you can mark is very important from examination point of view. So that's all I have from this lecture, and I hope that you will be able to understand the concept used in this question. So very soon I will be with you with my next video lecture. Till then, take care, bye bye, see you soon. This is Dr. Rajesh Saini. This is saying you goodbye, take care, bye bye.